Okay, welcome everyone. Thank you very much for coming. I hope you're having a very good TechEd so far. My name is David Zipkin. I'm a product manager on Windows Vista, and this is Elsie. She is a program manager on the reliability features, and we are going to talk today about what we've done to build reliability into Windows Vista. So over the course of this talk, we'll get into the improvements to the kernel, the new features, as well as changes to the actual development process that we've made in order to improve overall reliability. But before we get into those details, which really are the meat of the talk, I wanted to just spend a minute or two describing how we view reliability, which really comes directly from how you view reliability. Now, over the last couple of years, we've done a lot of research and talking with our customers. I believe we did over 5,000 surveys and interviews to really understand what people think about when they hear reliability. Because I'd say at first glance, reliability can often mean just no crashes and hangs. But it turns out it's so much broader than that. Right? It means so many more things to different kinds of people. So just so I can get a sense of this audience, who here is an IT professional or works on infrastructure? Great. Wow. Any developers in the house? It's okay, just a couple. Good. Well, I think our talk actually is geared primarily towards IT professionals, but we are going to put in a number of facts and information for developers too. So it should be a good mix. When we did those surveys, we learned how different people and different types of workers think about reliability. This slide is obviously a simplification of that, but on the high level, developers, they need a platform that makes their products look good, right? A stable platform that's going to be responsive and reliable. And additionally, they also want a way to get feedback about the software they write. Now, IT professionals are a bit of a different story. They just need rock-solid stability in operations 24/7. When you talk to consumers, it becomes much more personal, and it's about having your photos, your life, safe and trustworthy, knowing that you're not going to lose that if something happens to your computer. You also hear a lot about frustration regarding plugging devices in and getting things to work with the computer. So all these really constitute what is reliability. And then closing on knowledge workers, we heard from knowledge workers that they also don't want to lose their data, and they also need a consistent work environment that doesn't get buffeted by crashes and hangs. They want to be able to do their job and not have to deal with the side effects. So we took all this feedback and we tried to boil it down and to distill it into a couple attributes that we could really use to guide our development, to make sure we're hitting the key points that we heard from all of the customers. And it comes down to these 5 focused attributes. The first is predictable. And this is really about, my computer just works the way it should. When I plug something in, it just works. It doesn't crash, it doesn't hang. A year from now, it works the same way that it worked when I first got it. These are our goals. Computers, they really are just always there and just trustworthy and reliable for you. The second is resilient. When crashes do happen or when hangs do happen, the computer needs to be resilient to those. One crash cannot or should not take down the whole computer. The computer needs to be responsive and continuous over the course of day-to-day life as a computer. Onto recoverable. So part of my job is to talk to a lot of customers, and I hear tons of stories. And actually part of working for Microsoft is that you just hear tons of computer stories from everyone you speak with. And the stories that are the most heart-wrenching are always the ones about data loss. So crashes and hangs are still going to happen. And when they do, we need to make sure that they really affect data last. Data needs to be recoverable if something happens, and we need to make sure that in the event a computer is in an unstable state, well, the data is going to persist beyond that. Onto proven. One of the, I guess, most hard-hitting comments we got in that 5,000-person discussion was that someone said to us, your software is like bananas. You don't ship it when it's ripe. You let it ripen with the customer. And we really want to change that perception. So we've done a lot of work in Windows Vista, and the same for Windows Server codename Longhorn, to try and change that perception, to make it that the computer is shipped ready. When we RTM in October and ship to consumers in January, that you will all trust that this is a proven OS and is ready for deployment and for use. And finally, maintainable. Now, the fact is we are going to need to put out updates at some point. And those updates need to be simple to install. They can't affect other applications. They can't affect application compatibility. They just need to be simple and easy to configure and manage. So why so much attention to reliability? It turns out, and this probably is not a surprise at all, that reliability has a really, really powerful effect on customers. When we look at dissatisfied customers, over 50% of dissatisfied customers point to reliability as the cause for their dissatisfaction. Now, on the positive side, too, it's a customer delighter. Customers who are happy point to positive reliability experiences, many of them do, as the reason why they have a good experience and a positive experience. So there's so much impact to reliability that we really want to make sure we do a good job with it and get it out to the customer in these new versions of Windows. It also can affect support costs. A more reliable client operating system means that your users are going to have fewer disruptions during the day. That means less indirect costs for their downtime, and it means less direct costs for the help desk having to fix, diagnose, re-image, whatever it takes. We also think that by improving reliability, we can further lower help desk costs by putting in features like auto-diagnostics and improved help that really help users solve their own problems, limiting the number of times they need to call a help desk. Because the numbers show that one call to the help desk can be, at a low end, $20, upwards of 50 or more. And finally, we want to add features that make it easier for IT professionals and support workers to help the end user. Now, the way the rest of this talk is going to be structured is really around these three goals. We're going to talk about the improvements to the kernel, the improvements to the features, and changes in engineering processes that help us deliver these three areas. And we'll go through them feature by feature. In fact, Elsie will go through them feature by feature. Why don't you take it from here, Elsie?
Okay. So the first area that I'll go into is fewer disruptions. And so what we have done in Windows Vista to reduce the number of hangs, crashes, and the other types of disruptions. So the first thing is, how many people have heard about the SDL, or the Security Development Lifecycle? Right, a few people. So a lot of people are aware that Microsoft uses SDL, but not many people are aware that we do a similar process for reliability engineering. We don't wait until the end. We don't wait until a few months before we release a product to go and make sure that the product is reliable. We incorporate that into all the stages of the product cycle. So we start with design. And in design, this means designing features and improving the architecture to make the system more resilient. And I'll talk about some of the specific features we have in Windows Vista to make it more resilient. Then the other part is when we're testing the product, we still have to test for reliability. So reliability testing is commonly, it's more than just injecting faults and testing your component under that. We also do we do that, but in addition to that, we also test for problems like memory leaks, things like hangs and crashes, and we do that during testing. We also set a reliability release criteria for each of the major milestones, and we won't go past that milestone if we haven't reached our reliability goal. And this was something that we started even before Vista in Windows Server 2003. We also use customer feedback, so we don't wait until we ship Windows to get customer feedback. We get that during the development cycle. So right now we've got a lot of data on application crashes, hangs, and other problems through the Windows error reporting. And since we released Beta 1 last year, we have been monitoring all that data, and we've been fixing the common hangs and crashes that we've seen. And then the last part is when we do get the customer feedback, make sure that we provide solutions to the customer. So, and sometimes we might even need to provide an immediate solution to a customer if it's a critical problem. So moving on to the features that we have in Windows Vista that will reduce disruptions. So the first area is reducing hangs. Now, hangs are the biggest reliability problem on client machines from a knowledge worker perspective. In Windows Vista, we have three main things we've done to reduce hangs. So the first thing is we now have cancellation APIs. So this is cancellation for I/O. Before Vista, a lot of I/O operations couldn't be canceled, and so what would happen is when a user tried to close an application, and if it was doing some long-running I/O, or if a driver that it depended on was doing long-running I/O, the application would just wait on that and it wouldn't close, and to the user it looked the application is not being responsive. And there was really nothing that the application could do at that point. Now in Windows Vista we can cancel pretty much most of the I/O APIs, including things like create file, which was a commonly which usually was a long-running API that was used frequently. We also have deadlock detection. Now, deadlocks have been one of the most hardest causes of hangs that are very difficult to diagnose. Now we have a built-in detection and diagnosis for deadlocks. We have what's called weight chain traversal, and we look at we monitor who's got a certain who's waiting on a particular operation and what other application is also waiting on that, and report those to Microsoft so that we can go and remove more deadlocks. We also have improved the way we report hangs and diagnose hangs, and this allows us to fix more hangs, and that will help us provide more solutions to customers when they experience hangs. The second area is crashes. In crashes, we now have registry protection. So this will prevent users from changing system settings that could make their system unusable. We also have APIs through the Windows error reporting infrastructure that applications can use to go and recover data when after an application crashes and hangs. And we'll show you a demo of that particular feature in a few minutes. The third type of disruptions are reboots and other types of disruptions. So for reboots, we have the Restart Manager, and I'll talk about the Restart Manager on the next slide. And in addition to the Restart Manager, we now have, for the first time, built-in memory leak detection. So what happens here is in Vista, we're continuously monitoring all the applications on your system, and when we think an application is consuming too much memory, we automatically turn on memory leak diagnosis for that particular application. At that point, we track all the memory allocations and all the frees that application makes, and we do this with little to almost no impact on the performance of the application. Then when the application shuts down naturally, during the shutdown path, we go and we look at what pieces of memory have actually been leaked, and we report that automatically to Microsoft. We also have the Windows error reporting infrastructure. Now this is not new to Vista. It's been there since Windows XP. We've made a few big improvements in the Windows error reporting infrastructure. So the first thing is we have more types of problems that are reported in real time back to Microsoft. So memory leaks, as I mentioned before, is one of the new types of problems that we now report. Applications can also report other non-critical types of problems. And information on how to do that is actually in the SDK. We also provide fixes for more types, for more problems. Now, we had a lot of feedback before Vista from customers saying that they didn't want to send us data when their applications hanged or crashed, because all they saw was this data going to Microsoft, and they didn't see any improvement on their machines. So now we're providing more fixes to the problems that they've experienced, and that should also encourage customers to send us more data. So the final thing before we go to the demos is I'm going to talk about what we're doing to reduce disruption from reboots. So in Windows Vista, we have the Restart Manager technology. Now this is just an infrastructure that if applications and if installers use, they can reduce reboots from installing updates and installing applications. So Restart Manager, using some changes made in the kernel, we can now detect very accurately the minimal number of applications and services that need to be shut down to replace a particular file or a resource. And we have the ability to shut down those applications and services and do that without requiring user input, and do that automatically using the same notifications that applications get today during system shutdown, which means applications don't have to change to use this particular feature of Restart Manager. Then another feature of Restart Manager where applications will have to change is Restart Manager can restart applications, and in some cases we can bring back the application to the same state that it was in before we shut down. Now, in order for Restart Manager to be able to do that, the application has to be able to save its state and register with the Restart Manager to say that it supports saving its state and provide a way for us to restart the application. And we'll show you a demo of how that works. The other key benefit with Restart Manager is when a reboot can't be avoided, in those cases, any applications that are Restart Manager aware can be restarted after the reboot back to the same state that they were in before they were shut down. And the other Windows installer is the first installer to have built-in support for Restart Manager. So if you build an application using Windows Installer 4.0, which is a version that's in Windows Vista, you'll get Restart Manager support for free. And key applications in Microsoft Office 2000 are Restart Manager aware. So with that, I'll go to the demo. So the scenario here is, imagine it's the day after Patch Tuesday. Imagine it's 3 o'clock in the morning. I'm the user, and I've left all these. I've been working on an Excel document, and I've got a Word document open, and I have some unsaved work. And you're the IT department, and we're trying to push down a patch in the middle of the night. It's a critical security fix. So before I do the patch, I'm just going to I'll modify the data here, just to show you that it hasn't been saved. So I'll just say Northbridge, and I'll install the patch over here. So what you've seen here is this particular package was built using MSI 4.0 to take advantage of it. And now it's telling me that Microsoft Excel and Microsoft Word need to be shut down in order to avoid a reboot. But for this particular demo, I'm going to show you the case when the user is not at the machine, or if the application was not built to use Restart Manager. This is the experience that you'd get. So in this case, I'll choose not to close applications. This means that a reboot will be required, and I'll choose to reboot the machine. So in this particular demo, it's been interactive, but the same thing will happen if you installed an update from Windows Update and you had a 5-minute countdown, and then Windows Update would automatically restart your machine. At this point, we're going to switch to another demo, but what you will see is the machine will restart, and then we'll come back to this demo, and I'll show you that if the applications have been restarted.
So the goal of Restart Manager is to avoid the reboot if possible, but it's not always possible. In fact, it's not possible in a lot of cases. So in that case, to make the reboot as little a disruption as possible, such as saving all of your state and then rehydrating that state exactly where it should be. So while this reboots, I thought I would do a few more demos that go under the bucket that we're in right now of reduced disruptions. So the first one is a demo of something that Elsie mentioned, which was the cancellation of synchronous I/O. And I've got a notepad file here, and I'm just going to try and save it. And I'm going to save it to a made-up file share. Now, pre-Windows Vista, this would have spent, I'm going to hit save, a lot of time searching for it. And I couldn't have stopped it. But now we use that new API to let me hit cancel and continue on with my work as soon as I realize I didn't make the typo. So I don't need to wait for the computer to search all possible aspects before finding out that it's not a valid path. I can just go ahead and cancel it myself. The second thing I wanted to show was an example of how we're dealing with crashes and hangs. So what I have here is a Word file, and I made this a few minutes ago, and I'm going to simulate a hang. So let me open up my hang program, and I will. This isn't available to the public, by the way. This is internal only. You can't have this if you want it. So I'll inject my hang. Give this a second to let that get there. But what we're trying to do is make even hangs consistent experiences. So now we see, okay, it's not responding. It's noted up there on the top, but there's still some level of responsiveness. When I click anywhere on the document, it frosts the whole thing. So no longer do I have sort of a partially redrawn screen. At least I know what's happening here. I know this application, in fact, has frozen. And I see that my computer is responsive in other ways. I can still move windows around and so on. Now when I try and cancel it, when I try and close it, it gives me the option to restart the program, again using the APIs that Elsie mentioned earlier. Oh, and also notice how it's frosted the other window too behind it, the other Microsoft Word window, letting, again, the user know exactly what's going to happen when I go ahead and say, restart the program. So both these are going to be closed. Now it says here it's checking for a solution to the problem. We are looking right now at Windows Online to see if this is a known problem. And if it is a known problem and there is a known solution, that solution will be available right away. You'll get a little blurb in the bottom right that says, a solution is available. Click here to install it. So we're trying to really increase the time or decrease the time in that feedback loop so that when there are problems, boom, you get the solutions right away. If there's not a solution, what will happen is we're going to log this. And we keep a list of the most common problems, and those are where we begin making our solutions first. We try and affect the most common things before we move on to the less common things. So click cancel. So now it's trying to recover my information. And it's doing this, Microsoft Word is doing this. We've given the application the chance to go in there and do any kind of recovery that it can. So we're sort of giving it a hook via the API. And at that point in the process, Microsoft Word is going to look at its temp files, do whatever it needs to do to recover. Your applications, if you're developers, will also get the chance to do any kind of recovery before the application is closed and all that state is lost. So it's a chance for those apps to work, but we don't do the work for them. All right, so that is sort of the new hang experience. Hangs, we're doing our best to prevent them, but when they do happen, and they still may happen, we want to make sure it's a consistent, reasonable experience. Okay. So let's go back to Elsie's demo and see how the Restart Manager did.
Okay, so I've come back in, it's the next day, and I'm logging back into my computer. So as I'm logging back in, my applications will get restarted.
And this works with Microsoft Word, Excel, PowerPoint, Outlook, and IE7.
Okay.
And there are APIs, so any third-party applications can also write to these APIs, and they can also be restarted intelligently after the reboot.
Right. So you can see this is the Word, this is the text that I'd saved, and the application has come back.
Great.
Okay, that will go back. So that covered our first section on what we're doing to reduce disruptions in the first place and prevent a support call. Now we'll move on to the second section, which is when a disruption does happen, how in Windows Vista users can now go and solve more problems themselves through auto diagnosis. So we have a few scenarios where we can automatically detect the problem and diagnose the problem, and in some cases even automatically repair the system. So the first area is we have resource exhaustion prevention. So today, not sure if many people might have noticed a little notification or a little balloon that you get that says your system is running low on virtual memory. Now, so the first thing is that warning is not very helpful. And usually it comes too early before your system is actually really low on virtual memory. And most users don't know what to do when they get that message, and they typically just go and hit dismiss. So in Windows Vista, we now have a way to detect when your system is about to get into memory exhaustion. And we detect it before it happens to prevent data loss. And at that point, you'll see a dialogue that explains what's happening, and will also give you prescriptive actions on how to recover your system. And we'll show you a demo of how that works. We also diagnose some hardware failures, and we do this for both disk and memory. So for disk, we use the smart data if it's available on the disk, and we use that to let the user know if their system has a bad disk. And we do that early so as to avoid data loss, and the users can go and back up their data. We also do that for memory. And for memory, we actually had a memory diagnosis tool that was available on Microsoft.com on Windows XP. Now in Windows Vista, it's built in, and it can run automatically anytime that we detect your system has crashed because of a data corruption problem. We also have diagnosis for networking problems, so for wireless and wired networks. We also have diagnosis for some common performance problems. This is on client, so if your machine is slow to start up, or slow to log on or log off, or slow to shut down, we have this performance diagnostics that will tell you why your system was slow and give you some kind of prescriptive actions that you can take to speed up your system. We also have detection against corrupted files. And so this works against corrupted system files, and in these cases we detect it automatically, and we can replace the corrupted file from a cache. We also have the Program Compatibility Assistant, and this works both when you're installing an application and when the application is running. It looks for common or known compatibility problems, and at that point a wizard comes up and walks the user through a series of steps that can get the application to work. So some of the problems that it looks at are some problems with Lua. This is when the application is running. Some of the problem during setup is it looks for whether the application needs to elevate, or if it doesn't write an entry into the add remove programs, which is a common error that we've seen, or if it doesn't set a key to delete all its files after uninstall, which is another, or an OS version check. So those are some of the types of problems that it looks for. And we'll show you a demo of that. The final area is unbootable systems, and I'll talk about that. So for unbootable systems, we have the Windows recovery environment. This is based on Windows PE, and there are two main things you can get from Windows RE. So first is automatic diagnosis and also detection of unbootable systems and repair. And we'll show you a demo of that. Right now, Windows RE can repair up to 80% of the known causes of unbootable systems today. It also provides options for support to do more manual repair, and it's also extensible by the OEMs. Windows RE replaces the recovery console, if you knew what that was in Windows XP. It's currently not released or it's not installed when you set up Windows Vista. So the way it's available through 3 main channels, we release it on the OPKC DVD or the Wake DVD, and that's to OEMs and to corporations. And consumers can get it through on the setup DVD. So now we'll go into a demo of WinRE. So what I have on this machine here is I have 2 partitions. I have one partition that's a hidden partition that has the Windows recovery environment and WinPE. And I've booted into the Windows recovery environment. It's available by pressing F8, if you know how to do that. F8 was the menu that you could use in XP to boot into things like safe mode and the different types of safe mode. So I've got into the Windows recovery environment. Now this is the manual repair menu, and this is what we'd expect only advanced users to see or support to look at problems that cannot be repaired by startup repair. So through the recovery menu, you can now do things like system restore, which wasn't possible with the recovery console on XP. You also have the complete PC option. Now, complete PC is a new backup that we have in Windows Vista, and this will search for any backups that you've created on your system volume, and you can restore your entire disk from the backup. We also have the memory diagnostic tool. I'm not going to run it, but I'll just show you what you'd get if you click on that. So the memory diagnostic is run when the system is starting up. So you can choose to reboot now, or you can choose to run it the next time your machine starts up. So with that, I'm going to go into the command prompt and create a problem that will make the system unbootable. So this X is the partition with the Windows recovery environment. C is the partition, is the system volume. So I'm going to navigate to system 32 so that I can remove the software registry hive. So I'm not going to delete the entire software registry hive. I'll just move it to another location, which to the operating system will look like a corrupt registry. So I'm going to move software. And by the way, I have to do this from WinPE. I can't do this from the main operating system because we have registry protection, and so I wouldn't be able to go in and just delete the entire software registry hive. And this is from a previous copy that I have. This point. So I'm restarting my machine, and what we will see is when my machine starts up, you'll see a blue screen, and that's part of the demo. It's intentional in this case.
So hopefully you'll see it on the big screen, but if not, you guys can see a flash of blue over here. We don't usually try for this in demos, but this is special.
And the reason we're demoing this is because registry corruption is the biggest cause of unbootable systems today. More than half the problems we've seen today are because of registry corruption.
Right. And the goal of this tool is to solve the 80% most common causes of non-bootable systems, which are traditionally very hard to solve because you can't get into the system to troubleshoot it.
Yeah. So if you can't see, the system's restarting right now. You can see the Windows is starting menu.
Okay.
And there's a blue screen that says that the system couldn't find the registry hive.
Okay. So now while it restarts, I'll do a few more demos. But one of the key things about this demo is we're going to do a lot of user interaction. There's timers and everything. So conceivably, the user could go and get a cup of coffee, and it's going to fix this problem on its own without the user having to really be too involved at all. So let me go back to my machine. All right, and I wanted to show demos of a few of those other features. Let me start this one going, and then I'll talk about it. This is going to be a demo of resource exhaustion prevention. So I'm launching a number of applications now that are going to just use up all the RAM I have in my computer. And as Elsie said, on XP, what happens is you might get a little bubble saying your virtual memory you don't have enough virtual memory. But really, to solve the problem, the unsophisticated user will have to reboot. And the sophisticated user will wind up going into Task Manager, finding the process that's causing the problem, ending that process. Neither is really appealing. Right? One is over the heads of most, and the other, well, it's a big disruption. So what happens now is that we're going to identify which application is the resource hog. And we're going to give the user a really simple alert saying, we've identified the problem, and here's how you solve it, which is the theme of all of our diagnostics. We want to help the user identify the problem, and then wherever possible, tell them how to solve it too. So here it is. It says, Streetmark Budget Software, that is the program that is using the most resources. Click here to close it. And we do, and it closes the offending program, leaving me the rest open to go ahead and work as I need to. So let's talk now about disk failures. So I'm going to simulate a disk failure here. And this can be a debilitating problem, because when a disk fails, generally you lose a lot of data also. And the idea behind this diagnostic is to work with the hard drive's smart diagnostic, which is effectively an indicator that a disk may be likely to fail. And when the disk fires a warning, we're going to convey that warning onto the user and do one of a couple things. In this case, we're going to give the user a big warning that says, Windows has detected a hard disk problem. We suggest that you back up right now. And this probably means that you have 24 hours to a week, depending on the hard drive. It depends on different manufacturers fire this warning at different times. So I can go ahead and start the process and go ahead and back up my software. But we showed this to a lot of IT professionals, and the first thing they say to us is, please don't give my users a warning saying your hard drive is going to fail. This is just going to cause users running down the halls, banging on IT's door. So this is all configurable using group policy. And what I can do with group policy is say, run the diagnostic, but don't actually give the user an alert. And instead, we'll just confine that alert to the event viewer. And then the IT professional, using a tool like MOM, or a new feature in the event viewer like event forwarding and event subscriptions, can be warned when this is going to happen. And this really enables the hero scenario. So instead of being on the receiving end of I lost my data, I lost 2 weeks worth of work, you can now be on the end of a phone call saying, look, we had a warning, we'll come by in 2 hours with the hard drive, don't worry, we're going to make sure everything's okay. And it's really, I think it's a nice way to twist the situation around and provide a real good proactive service to in-house clients. Let me show you where this is. I have a filter here. This is a custom view set up to catch all kinds of diagnostic alerts. And here we go, 323. So that's the one I fired just a couple seconds ago. And then I can, of course, right-click on this and say add a task to the event. So fire off, say, an email whenever this happens, or have it forwarded on to a different PC. Great. The last demo in this area I'm going to show is the PCA, the Program Compatibility Assistant.
So what you see here, Startup Repair has finished diagnosing the problem and also repairing it. Now, the reason it stopped is because I've stopped it. If I hadn't stopped it, it would have automatically finished and restarted the machine so that it could boot back normally. I just stopped it here so that I could show, for at least in the demo, what happened. So this is the detailed diagnostic log that lists all the things, all the diagnostic actions that were taken, and also all the repair actions. So here we have the number of different tests that were performed. So you can see we checked the disk metadata and a number of different tests. And then right at the bottom, it detected that the registry was corrupt. And in this case, it performed a system restore. Normally, it would also choose to do a registry rollback, because those are the two repair actions for a corrupt registry. We can roll back the registry or use system restore. So with that, I'll hand it over to David. We'll come back to this. I'll click Finish so that it can go and restart the computer and boot back into Windows Vista.
Great. And that's a useful scenario, I think, in the office, where instead of having to reimage, a user can really self-help and fix their own computer. But it's an even more compelling scenario for a traveling user, where a person is in a hotel room and has a series of meetings, and they're really outside the reach of corporate reimaging. And this is a way that they can actually be up and going and productive again. So the last demo out of the three that I wanted to show was the Program Compatibility Assistant. And where this really comes into play is when you're upgrading to a new version of the operating system. You have all this old software you've already bought, you install it on Vista, and what's going to happen? Some of it's going to work, some of it may not be compatible. And it turns out some of those incompatibilities are really small, insignificant ones that are easy to fix. So this is where the PCA comes in. It can fix those easy ones. So this is a Microsoft piece of software that I'm going to try and install. It's for IntelliPoint. And let's see what happens. So it installs, and I get an error that says, your computer does not meet the requirements. This is not running XP or Windows 2000. Now, in fact, it's running Windows Vista, which is even more advanced, but the software doesn't know that Vista exists. So a lot of software applications require XP or 2000, but they don't really need it. I mean, they work just fine on Vista. So what we can do here is actually just do what's called a shim and give a white lie to the piece of software that says, yes, in fact, this is XP. And the software is happy as a clam. So my hands were off the computer, and the PCA basically went ahead and said, I saw that you had a program that didn't install correctly. Maybe I can help. So now we reinstall using the PCA, and it's going to put that shim in and let the piece of software install. And in fact, this time, the OS is going to report that it's running XP and not Windows Vista. And as you can see, it got a bit farther than it did last time, preparing to install. And here we are. So simple fix. And we have fixes like this for a lot of common programs. And that's the idea of the PCA.
So this is the machine that was previously unbootable. Now I've got to the logon screen, which I couldn't get to before. So I'll just log back in to show you that it's that startup repair managed to fix the system, and it's logging back in at this point. I've repaired my system. So with that, we'll go to the third section of the talk on how users can support themselves and fix more disruptions on their own. So there are two key areas here. The first is problem reports and solutions. And here it's for a user, if they're having a lot of problems on their machine, if they're experiencing a lot of crashes or hangs, they can go into the problem reports and solutions, and then look at a history of all the problems they've had and also check for solutions. And we'll show you a demo, which will give you a clearer idea of the capabilities there. The other thing we have is improved help, and so there's three main things in improved help. We have guided help, and it's much better to see the demo. The demo will speak for itself. In addition to guided help, we continuously update our help content online right now, and this is driven by the customer feedback we get. And corporations and OEMs can also add more content to help and customize that. And with that, we'll go to the demo for problem reports and solutions.
Great. So we want to help users understand what's happening on their computer. And we can't always diagnose everything, but we can raise flags and let them have the information they need. So Elsie mentioned problem reports and solutions. And you can see here that, let's say an application crashes. Well, if there's a solution to install, it's going to appear right here. In this case, there aren't any solutions to install, but we are reporting an error that we had via my antivirus. You can also look at our performance ratings and get diagnostic information about how my computer is performing. And here it says that I have programs that are causing Windows to start slowly. I can see details on that. Or I have drivers interfering with Windows. If I open up either of these, I will get guidance on what is causing my computer to start slow, and then the help file will teach me how to take that out of the startup path if I need to. Now, additionally, we talked about guided help, which is a very cool feature. Let's imagine that I'm a user and I want to figure out how to show those hidden files I have in my PC. And I know I did this once, but it was kind of buried beneath some tabs. There was a couple buttons I had to push. I just don't know where it is. So I did a search in help. And I found, I did a search for show hidden files, and the first result is a guided help result. And I know this because there's a compass there. Now, I can say, show me step by step. And now it's like having someone stand over my shoulder and basically tell me where to click in order to show all those hidden files. So, and I can just continue going this way. Or I can sit back and say, you know what, just do it for me. And then I'll watch as it goes through all the different steps. And I can learn this way. And most importantly, because it's much easier to do than read those somewhat dense help files, this can save a call to the help desk. This can really save some money.
So moving on to the third area, which is, so now when you have disruptions and users can't fix them on their own, or the system can't detect and repair those, then in those cases we have some new capabilities that will make it easier for support to go and diagnose and fix those problems. The first thing we have is a reliability analysis monitor, and this is new in Vista, and it provides it uses data from a lot of different sources. So, for example, the system event log, WMI, and a lot of other data sources, and it looks at all of this data. And using that, it compiles a report on the reliability of your system. And it provides those metrics in an easy and understandable way. And users can also use the reliability monitor to understand why their system is behaving poorly. So, for example, and we'll go and show you more of this in the demo, but for example, if your applications are crashing very frequently, you can go in and look at, go into the reliability monitor, look at what happened, look at your reliability rating, and then after that, can go and see, okay, were there any system changes that you made before the application started crashing, and maybe that could have been the cause of the crash. So these type of correlations between disruptions and other types of system change events are used quite frequently in the reliability analysis monitor. And this uses more than just the data that you have today in the event log. So in addition to the reliability monitor, we also have remote assistance. Now, remote assistance has been there in Windows XP. The main improvements to remote assistance are, the first thing is it's much faster. So it's much faster to connect. And also, there's more things that can be configurable through group policy. So for example, if you wanted to increase your bandwidth, you can choose not to show the desktop remotely. You can also choose to customize the text and the error alerts. And it's actually probably better for us to show a demo of this than going through it.
Great. So let's talk about the connection scenario. So remote assistance has been totally rewritten. It's now a standalone app, and because of that, it's much faster. We heard stories of some companies having connection times of upwards of 30 seconds. So I'm going to initiate a connection with this computer over here. There are many ways to initiate connections. Right now, we're doing sort of the standard way. Elsie had emailed me a file earlier, but remote assistance works with IM clients. It works with Windows Communicator. It now, via group policy, can be configured so that certain people in your organization can be added to the group of people who are allowed to offer assistance. So your help desk doesn't need to anymore wait for someone to go out there and ask for help. They can get a phone call and say, okay, I'll go right to your computer. But only for that small group of folks who have that privilege in Active Directory. So let me go ahead and type in the password, and I'll hit enter, and Elsie will hit yes, and we're up. And so it's pretty quick. You can do it in really a second or so. Now, I think it's an interesting scenario to consider how this works with Reliability Monitor. So I'm going to take over control. And before you hit yes, notice that there's a customized message here. It says, Contoso company policy says you must remain in your seat during this remote assistance session. This is now configurable via group policy, so you can remind everyone that this is somewhat of a security risk. If you don't trust the person on the other end, you can remind them what the company policy is. You can tell them whatever you need to, again, via group policy. So different people can get different messages also. So Elsie's going to say yes. And now I'll show let me make this fit the screen. And here's the reliability monitor. And this is basically the story of my computer over time. So what we're looking at is a graph of my system stability. And we can see that, well, things were great in the beginning. Back in March, early March, I was 10 out of 10, which means that I had no crashes and things were stable and reliable. And then halfway through the month, all these X's began appearing. And these are crashes. Some are application failures, some are Windows failures. And if I click on any one, I can see what's causing it. And it's an application called accounting.exe. Now, I also see that there's an I here. And this I, well, that's information about an install. So this is not necessarily saying the two are related, but they are correlated in time. And if I'm a person who's trying to solve this problem, well, I can see that just before all these crashes happened, there was an installation, which means there's a pretty good chance that there's a correlation between the installation and the crashes. So as the help desk worker, I can then go in, and in fact, I did choose to uninstall it on this day after those crashes, and I saw that my computer no longer crashed. And the reliability index, which is basically a moving average, a weighted moving average, it actually trends back up towards 10 because I didn't have any other crashes. So we think this is a really nice, powerful tool for helping IT support help users. Additionally, one of the other major improvements in RA, in remote assistance, is that it can now navigate NAT, or network address translation, much, much better. It uses Teredo. So we expect that it will work with 90% of the home routers on the market because it was much more difficult in Windows XP.
So the three main things to take away, the three main improvements in Windows Vista. The first one is fewer disruptions. So fewer hangs, fewer crashes. We now have a platform so we can reduce reboots after those patch Tuesdays or make them less disruptive.
And this is new features or new improvements to the kernel, as well as actually how we write software. It's us thinking differently about the process of writing software.
right? And then the second one is allow users to fix more problems on their own through auto diagnosis and through improved help and user support. And then the third one is when users cannot fix problems on their own, there are new capabilities that support can use to go and diagnose and recover from problems much quicker.